Lunch and Learn is an MFG radio network production brought to you by GIE Media's Manufacturing Group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition. Hello, I'm Jake Kaufman, Senior Editor for GIE Media's Manufacturing Group, and I'm happy to have you join us for our Manufacturing Lunch and Learn with Techman Robot. Techman Robot is a leading collaborative robot and vision technologies company dedicated to improving the world of work for businesses and their people through robotic technology applications. Today's presenter is Jason Lancaster, Senior Project Manager for AMET Inc., as he'll discuss how Techman collaborative welding robots can integrate with AMET's automated welding technology for stable results. Without any further ado, Jason, thank you so much for your time today. The floor is all yours.
Awesome. Hey, appreciate it. And thank you for this opportunity, Jake. Just wanted to give you a little bit of background on me and then introduce our company here. So again, my name is Jason Lancaster and I'm the Senior Product Manager for AMET. I've been with the company just about 15 years now. My computer will work here. Just wanted to give you a little bit of outline of what I'm going to talk about. Give you an introduction about our company and talk about some of the things we do control wise and also fixturing wise. So our company's an automated welding system manufacturer. After I talk about that, we will talk about some of the automation projects that we do, and then I'll get into our partnership with TM and some of the new cool technologies that we're working on. So first of all, AMET, like I said, we build automated welding machines for manufacturing companies. I'm sure all of you know some of our customers in aerospace and nuclear industries and some of those other things. We have currently 700 plus systems delivered in the US starting in 1989, and a lot of those are still operating today, a lot of those early machines, which is pretty amazing. Our headquarters there in Idaho in the USA, and then we also have a sister company in China that does some fixture development, and they also sell welding systems there. So the processes that we normally do are GTAW, or also known as TIG welding, PAW, also known as plasma welding, and then GMAW or MIG welding, SAW, also known as subarc, and then laser welding. These are kind of our main focuses, but we also get into other processes when our customers request it. So some of the industries that we are in are aerospace and nuclear industries. Those are probably our two main ones, but then we also get into construction, defense, food and beverage, oil and gas, power, transportation, and wind tower production. Those are our main industries. So our claim to fame in our company is mainly our controls, and I'll kind of explain a little bit about that. So we use technology called DSP technology for all of our communications in our controls, and that stands for digital signal processors. This is very similar technology to what everybody has in their cell phones and all over in other areas. So the advantage there is that these DSPs rapidly analyze and manipulate physical signals in real time. And what that means is we can process data information at higher speeds, and it gives us real-time control for improved accuracy. And the other part of that is that we really try our best to make sure the operators of our machines have a simple interface and everything's located in one place. Traditionally in the welding industry, you'll see operators that have 2 or 3 different control consoles. And so they're jumping around trying to start them at different times and make sure that that all works like they need it to. Where ours, everything's all built in, all of our motion control, all of our welding control, all of our sensing, everything is all built into one interface for the user. So if you look at this little map, you'll see these XM modules. You can think of those as kind of a computer with a DSP controller inside each one. So the first one on the left side is actually controlling the power supply. So we have a separate computer controlling the power supply, and then that feeds back to the main controller at the top center of the screen. That feeds the information to it so you can view the data in real time. The next one over is a fixture rotation. So this would be something that we would mount the workpiece to and rotate it, and the weld head above it would weld the part. So again, it has its own separate computer that analyzes the information and then feeds that to the main controller. And each one of these appendages has its own computer control, and that information gets fed back. So we do anything from the welding control to the motion control, turning the part, to system monitoring. Oftentimes we control the gas flow that's getting implemented into the weld. We precisely control that so that you can program it as a part of your weld. We monitor oftentimes the gas quality as we're going. So like I said, all these things separated and controlled by a single computer makes for fast processing times, and then it relays that information in real time directly to the controller. So if something's getting off, you can make adjustments on the fly and it makes for a really high quality weld, and that's what we're going for. Just real quick, these are some different packages that our controllers come in. At the bottom center of the screen is our XM controller. This has been our flagship since about the mid 2000s when it was developed. And then in more recent years, within the last 5 to 10 years, we've really been doing a lot of the X Pro, which you see on the screen. And the cool thing about the X Pro is the programming is, and same with the XM, they're very similar programming. The X Pro just has a lot more capability for high-end applications. But on the X Pro, all the interfaces are the same between each package, but each one comes with a little bit different function. So the one on the left is kind of our standard screen. It's a little hard to see, but along the top you have all the meters that monitor each welding parameter, like welding current, welding voltage, travel speed, that sort of thing. But weld is fully programmable in that screen. What's not shown here is we do integrate video as well, so that you're viewing the weld and you can actually see the weld puddle in the video. So standard screen there. The middle one there is called the X Pro Mobile. This is built on wheels, and it's a full control package. So the welding power supply, the welding cooler, all of that, all the sensing, all the power distribution is all built into one console. And this can be used with different fixtures. You can roll it over one day and control this type of fixture, and then you can roll it to a different one the next day and do a different type of welding. And all the fixture management is handled in the software. The one on the right is what we call our X Pro Portable, and this is built more for portable applications. And I'll give one example of that. These consoles all break down into separate pieces, and you can carry them like on board a ship and carry it through the ship hatch down into a remote location of the ship, and then set it up and do welding on board remotely. So that's just a quick overview of our controls. The other thing that makes us kind of unique is we do a lot of custom fixture design. So a lot of our customers will come to us and say, we need you to come up with a unique way to weld this specific part. And oftentimes we've done something similar, or maybe it's something totally brand new. We start sometimes from the ground up and design it all for custom from scratch. And you can see a lot of different shapes and sizes. The picture in the bottom right screen is wind tower type production. So you imagine those round cans could be upwards of 18 feet in diameter. So this machine that reaches out over top of that to weld that round can has to be really large. And then in the top right screen, this is more of a portable type of application where this weld head gets disassembled and fit down through portholes and then reassembled inside of a part. And so lots of different shapes and sizes. We're always doing new and unique projects, which makes it exciting. So wanted to get to the point where I talk about some automation. What we're finding in our industry more and more as time goes on is that there's a shortage of skilled welders and welding engineers in the nation. And because of that, a lot of our customers are pushing us more and more to automate more of the process. Welding can be pretty complicated, and so to automate it, there's a lot of things that have to go into that. And I'll talk about. I broke some of the automation down into three categories. The first is material handling. So we do get into a little bit of part loading and unloading, and then also automatic part positioning and fixturing. So once you have the part loaded, you have to hold it in place. And one of the things that happens in the welding industry or the welding world, for those of you that are familiar with it, when you start adding heat to something, it has a tendency to distort and move on you. And so when we say fixturing, that we're trying to hold it in place long enough to apply the full weld so that it doesn't move. The next category is part orientation. So part of that applies to identifying which part it is. So in a high production environment, oftentimes the manufacturers will implement some type of a barcode to recognize which part we are welding. And so we have technology to where we can read that barcode with a scanner of some flavor, and we can automatically load up the weld schedules or weld parameters for that part. And then the other element of that is alignment of the weld torch to the part. And we do that in a couple of different ways. We have a technology that's called virtual alignment, and that is where you have a weld seam, and so you manually drive the machine to specific points along that weld joint, and you record those data points. And then when you actually perform the weld, the weld head travels exactly that path that you taught it. And then the other part of that is called touch sensing, where we actually touch the edges of the joint and sense where there's changes, and we follow that path that we automatically taught. The last category is weld control. And so, as I mentioned before, we control all the elements of the weld really precisely: the current, the voltage, the feeding, the speeds, the travel speeds of the weld head or the rotation, depending on what it is. And we also can control some of the process, such as gas flow, oxygen content, those sort of things we monitor and sometimes control those things. Then also we have done auto detecting starting and stopping the weld. So essentially the operator could load a part, hit a go button, the part's clamped and fixtured, it starts the weld and stops the weld and ejects the part out of the machine at the end. So all you need is somebody to start the process. Um, then last thing is controlling tracking during the weld, and we do that in several ways with laser tracking and also through the arc. We sense the welding current or voltage through the arc during the weld. So that helps when you have some of that heat distortion that I was talking about. It helps control some of that as you're welding. Okay. So this particular one is a quick video I wanted to show that is a is just a simple seam welding. So you imagine a flat sheet of metal that was rolled into a circular shape. What we're going to do is seam weld this into essentially a round duct. And this particular application, or this particular project, is the part is hand loaded by the operator, but the machine takes care of the clamping, the centering, the clamping, so fixturing. It performs the weld, and then the machine actually ejects the part at the end. And so we'll go ahead and play that so you can see how that works. So he loads it onto a mandrel and pushes it up against a hard stop. And then these are centering blades that you see to center the part, the joint of the part. Now it's closing the gap of the that was there. Now it's performing the weld. I apologize for the video; it's a little spotty, but hopefully it gives you a good idea. Here at the end, you'll see it kick the part out, and then we'll show the finished weld. Pushing the part out now. Okay, and then I have one more example of kind of an automated type machine, and this is a touch sensing one. You'll notice that this is more of a curved weld path. Um, so this is a little bit challenging to travel that path precisely. But it will actually touch off both edges of the joint, and then it will calculate where the center point is and eventually perform the weld. See, it comes down, drives to one side and senses the edge, drives to the other side, senses the edge, and then we use some kinematics to evaluate where the center point should be, and we can actually track that joint to within about 20 thousandths of an inch or better. Okay, so the main topic I wanted to get to was kind of a new thing for us, which is using cobots. So we created a partnership with TM about two years ago or so. And one of the advantages to cobots, for those of you who aren't familiar with them, the cobot stands for collaborative robot. And that means that you can have it in a work cell or a weld cell next to an operator. Traditionally, robots needed a lot of safety precautions, safety fences, and so you were blocked out of the cell, and it was hard to get in and work on robots or work next to them. They took up a lot of space, and they were really complicated to program. So cobots appeal to us that they're simpler, they are a lot safer for people working beside them, and they take care of a lot of more complex type welding shapes or welding geometries. So this particular one is a TM12 robot. I won't go into details, but essentially it's a 12 kilogram robot, and I think it has about 1,300 millimeters of overall travel or stroke. So this is a MIG application, and I'll talk a little bit more about this. But I wanted to just talk about a little bit of the automation that we've done thus far in that time frame that we've started working with cobots. We did what's called barcode part recognition. So this is really similar technology, but what's awesome about the TM robot is that it comes with a built-in camera that can do some of the barcode recognition. And also TM has a what's called landmark technology, and I'll talk a little bit more about that, but that we use that for part alignment, and then also touch sensing, like we talked about, for more precision alignment. Okay, so the landmark, what you do is you set it up along part of the a lot somewhere on your workpiece that's recognizable and that's repeatable. And this is just a simple T-frame weldment that we tack welded together. But we essentially align it to two edges of the joint. And what that does is then the robot comes down and scans the landmark, and it uses these little squares that you see on the landmark to align itself in X, Y, and also Z. And if the part is tilted a little bit, it recognizes that it's at an angle. And what's pretty amazing about this is, let's say you scan it initially and it aligns, and then let's say you take the part and rotate it maybe 30 degrees or something. Uh, what'll happen is the robot will come down and scan the landmark, and it'll recognize that it's at that 30-degree change, and it will update its position based on that. So then we'll get to the touch sensing. So at this point, this is another video, but at this point we've already sensed the landmark, so we're aligned to the part roughly. And when I call it roughly in our terms, it's still really good precision after it sees the landmark. But for us, we like things really super precise, and so we developed touch sensing for the cobot, and I'll show you what that looks like. So we're going to come in and we're going to sense, we kind of know what the part length is already. It's pre-programmed, but we're going to come in and touch three edges of the part to precisely align so that we know exactly where the weld joint is. And then after it does that, you'll see it actually go to the welding position, and we've developed some oscillation, and we also tell it to weld the full part all the way around. Okay, so that was a fairly simple application, but what really appeals to us about the cobots is more complex things. So this part on the right side, a little more complex. What we've developed is the ability to weld, to touch sense and weld that entire component all in one shot. So you'll see that there's four vertical welds where the two or three plates meet together. So four vertical welds, and then also a kind of a complex path horizontally to weld the whole outside. Basically, all the vertical plates welded to the horizontal plate below. They do the outside and the inside. So that whole component, we would weld that in roughly 15 minutes or so, which is pretty amazing. Then when you move over, oops, go back here. So this other round part has what we call an intersecting bore, and you'll notice that the intersection on the outside is, we call it a saddle shape, or also it looks a little bit like a Pringle shape. That shape is pretty complex for a standard welding machine, and so what we've developed is a way to coordinate rotation of the main tube and actually travel the path with the cobot and weld the intersecting piece to the main tube. So just a couple of examples of more complex things that we can get into, but that's where the cobots really shine, is we can do things that are a lot more challenging and make it easier for a standard operator, maybe somebody that's not super skilled in welding, and we can control the welding. Um, Getting short on time here, but just a few things for the future that we're looking at are uh, live joint tracking, so doing more laser tracking during the weld. But then also we're looking. TM has some new AI capability that we're exploring, and we're hoping that we can do uh, even more advanced part recognition. Come up to it, scan it with the built-in camera, and recognize what part it is just based on the geometry and what the part looks like. So pretty exciting things in the future, and hopefully I'll have more information for a future uh, presentation. Yeah, that's all I had for today. It looks like we're right on time. We'll just turn it back to you, Jake.
Perfect. Well, thank you so much, Jason. And like you said, yeah, we do have time for a few questions. I know personally, after watching that, one of the questions I have is kind of what are the limitations when it comes to using a cobot for welding? Because it seems like if you can have the universal weld throughout, you don't have to worry about, the human error and things like that. Like what kind of would be the holdup for using the automated welding systems?
Yeah, one of the holdups is the reach and the weight on the head. So when we get into heavier welding, like sub arc welding, the weld heads get really super big and heavy and clunky.
Mhm.
So it'd be kind of difficult to do that with a cobot. You'd have to have quite a big one. I would say that was, and then also reach, and what we're doing to accommodate the reach challenge is that we actually mount the cobot to what I'll call a trolley, for lack of a better word,
Okay.
or something that can move. So if we're trying to develop it to where we can coordinate that motion, so that you can have a large tube with a lot of welds along the length, and so then you can travel it down into position, find the joint, do the weld, travel to the next one, if that makes sense.
Gotcha. Well, it looks like Brian in the audience wants to know for the touch sensing, are you using the Cobot's built-in sensors, or is that something that you guys were able to create?
That's something that we did on our own. It's a technology that we use on a lot of our TIG welding systems. But yeah, it is. We did not end up using the built-in stuff that TM had.
Okay, gotcha. And looks like there is not me, but there is another Jake in the audience who wants to know the greatest challenge you faced when integrating the TM for these applications.
Sure. So we ended up having, so TM had a lot of built-in capabilities for welding, and because of what we do specifically at AMET, we kind of go outside of the norm in the welding world and do challenges that nobody else will take on, which is good or bad, I guess, depending on how
Mhm.
you look at it. But the challenge we ran into is it didn't quite have some of the capability that we needed for our customers and our applications. But that's exactly one of the reasons why we ended up going with TM, because they had a fairly open source code to where we could develop some of those things that we needed for us on our own. And then they're really willing and awesome about taking some of that feedback and building it into their standard product offering. And so it's been a great collaboration along the way to build a product that's really going to be amazing for the industry.
Awesome. And Scott wants to know when it comes to the volume number of parts, what is kind of like that magic number to where this system would financially make sense?
Um, Boy, I don't know a good answer to that for sure. um, I would say, you just take a look at it from both perspectives, and generally when we're talking to customers, we can figure out kind of a rough cycle time based on welding speeds. And then as we add automation, you can talk about, okay, this is going to add so many seconds, and you can kind of just compare side by side and figure out if something's going to be worthwhile from an automation perspective, if it's going to save time. Another big one for us is we do such a good job at the control of all that, those processes, that's where we can cut down time and rework, especially because we're really controlling the weld process super well, and we've got one automation system I know that was having a lot of quality control issues, and as we went into fully automated system, we got their scrap rate really super low because the quality of the weld was so amazing, so good. I don't know if that answers the question or not, but
Well, I know we will be able to forward you Scott's information, Jason. So if there is any further information that he might need, we will be able to forward that to you. But
yeah,
that
that'd be
just
great.
about wraps things up. We'd like to say a massive thank you to Techman Robots one last time for today's presentation. And obviously, thank you to Jason Lancaster, the Senior Project Manager for AMET Inc. Thank you so much for your expertise today, Jason. I hope you have a great rest of your day.
Yeah, thanks for having me, guys. Appreciate it.